Hi grade 11s, we are starting a new topic. This is a topic that's done in paper 1. It's called patterns, and it's quite a small section in grade 11. It'll probably only take us 4 lessons to do in grade 11, and then in grade 12 we expand on this section quite a lot, and it's an important section in matric. So what you've done so far in grades 9 and 10 is something called linear patterns, which we're going to touch on. And then the new thing for grade 11 is the thing called quadratic patterns. Now, everything we learn this year is examined in matric. So even though it's a small section in grade 11, we need to make sure that our notes are good and clear so that next year when we need to study from them, it's quite obvious to us what we were trying to say. Simply because we very barely redo the grade 11 stuff in matric. We just expand on it and go into more depth. So let's just make sure that we write some good notes. So what we're going to do is we're going to start off. This video is probably going to be a fairly short one because it's literally just an introduction to the idea and the notation of sequences and patterns. Because actually that's where people fall down, is they don't understand the notation around this topic. So I've just got a whole bunch of questions here which I've asked just so that we can write some quick notes. So the first one says, what is a sequence? Now this is probably a more mathematical term than we've used in the past. A sequence is simply a list of numbers that have a pattern. So the question is, can you predict the next number in the list? So it's a list of numbers that have a pattern. And if you can predict the next number, it means that there's a pattern, and we call that a sequence. So it follows a certain pattern. So for example, I could use the multiples of 3. So 3, 6, 9, 12. And you'll notice I'm putting a semicolon between each number in the list. That's how we do it. And if I write dot, dot, dot at the end, it just means that the sequence carries on. It could carry on forever, or it could stop at some point. Right, so that's what a sequence is. Now the next word we need to know is what is a term. Now each number in the sequence is called a term. Each number in the sequence is called a term. And every term has a value. So for example, in the example that I've written down, this 3 would be the first term. And that brings me to the next particular question, which says, what does the notation T1 mean? T1 means the term in the first position. The term in the first position of the sequence. So this subscript here, a subscript, I'm sure you've heard that word before. You have a superscript, which is like an exponent, and a subscript is something you write below. This tells us the position of the term. Now when they say T1, they mean the value of the term in that position. So in this example, the first term, or T1, has a value of 3. We'll write that down in a second. Now our next question says, okay, so then what would T2 mean? Now T2 would simply be the value of the term in the second position. So that subscript just tells you the position that you're looking at, what term you're looking at. So the value of the term in the second position. So if we just look at this example that I've done here, 3, 6, 9, 12, which is the one I gave you, this would be T1. It means that 3 is the value of the term, in position 1. Now that's how I would say it in words. I would say 3 is the value of the term in position 1. How you write this mathematically is you would say T1 equals 3. That's what that means in English. It means the value of the term in the first position is 3. So just another example here, if I look at 12, this would be T2, this would be T3, this would be T4. So I would say T4 equals 12. That would be how I would write it mathematically. And in words, I would say the value of the term in the fourth position, or in position 4, is 12. So when you go to and you count up until the 4th position, the number that will be there in the sequence is 12. So as long as we understand what this subscript means and what the T4 means, the section will be a lot easier. So the last thing we need to know before we launch into linear patterns is, what does Tn mean? Now, given what I've said in the previous statement, Tn actually would mean the value of the term, in the nth position. Now, you don't know what n is because they've left it as a placeholder here. So this is called the general formula. If you can find an expression that is an equation that represents this sequence, that's called the general formula. So in this particular example, let me show you. This particular example would be 3n, would be the value of the term in the nth position, simply because that's the formula that can predict the term in every single position. So n will change. So for example here, I would say if n is 1, I would say the value of the term is 3 times 1, which is 3. If n is 2, the value of the term would be 3 times 2, which is 6. So this is just an expression that generates the sequence. It's an expression that you can use to calculate each term in the sequence based on what n is. So that's called the general formula, or the nth term, otherwise known as Tn. Okay, so this is basically all the notation we need to know. Now we can start our two topics. The first one's going to be linear patterns, and the second one quadratic.